Hey guys, so I'm making this video to help you with the mastery test for similarity, proportion, and triangle proofs. Now, the proof part is really hard for me to show in an online way. So the best advice I can give is to make sure when you're going through the tutorial for this, you spend extra time on how they construct the proofs in the order they go in, because the reasons which go on the left and the statement which goes, the statement which goes on the left and the reason which goes on the right are really important, and they're going to be using a lot of the similar examples in the mastery test they did in the tutorial. So make sure you maybe spend a little extra time on those slides as you go through. What I want to talk about is when they have triangles and they start drawing in parallel lines and altitudes, how they're creating similar triangles within the triangles. So first things first, if you haven't noticed already, the symbol for congruence, right, is kind of like an enye with an equal sign underneath it. So that is our congruent symbol. The similarity symbol is just the enye. So if I wanted to say that two triangles were similar, I could say triangle ABC is similar to triangle XYZ. Alright, so that's what that symbol means. Similarity. So when you draw in lines that are parallel to sides of triangles within triangles, you create similar triangles. So if we look at this first diagram in the top left, if I say that these two lines are parallel, alright, that's a symbol for parallel, then that means the big triangle is similar to the little triangle. Meaning that corresponding angles are congruent, right? But also that the sides are proportional. So this breaks it up in a couple different ways. So let's say, for example, that this side length is A, this side length is B, this side length is C, and this side length is D. Now, if that is the case, you can write proportions. Remember, proportions are two ratios that are equal, like a fraction equals a fraction. You can write the ratios in two different ways, and you still get the same answer. I can write A over B equals C over D, or I can write A over C equals B over D. Because when you compare those two proportions, alright, that is, you're still, when you cross multiply, the same things are getting multiplied together. A is still getting multiplied by D, and B is still getting multiplied by C. So the way that I usually do that is I go top over bottom equals top over bottom, or you do left over right equals left over right. The key thing is knowing that you're either separating by the side of the triangle or you're separating by above or below that middle parallel line. Now the reason they're similar is because if you notice that top angle, that's what we call a reflexive angle. That angle is being used in both triangles. Also, since we have parallel lines, this angle and this angle are corresponding because this is our transversal, and corresponding angles are congruent if parallel lines are cut by a transversal. So, if I know that there's two pairs of congruent angles, that's enough to know similarity for triangles. So, if you have horizontal diagrams like this, that is the best way to make the ratios and then be able to solve for missing side lengths. Okay? Let's go to the triangle below. Now let's say your parallel lines are like this. And let's say I'm trying to find one of those missing links. The same rule can apply. Left over right or top over bottom. So I can do x over w equals y over z, or I can do y over x equals z over w. You just have to keep the order consistent. So when I was doing x over w, I'm doing left over right, left over right. When I was doing it the other way, I did top over bottom, top over bottom. Okay? So the sides get mixed up because they're similar. These sides are proportional. All right? They are proportional sides. So that means that you can set up the ratios just like that. All right? Hopefully that's helpful. Now for the right triangle where they draw on the altitude. So this is where it gets maybe a little confusing. So imagine I have a right triangle, and then I want to draw an altitude from the hypotenuse of that right triangle. The hypotenuse is the side opposite the right angle. So that means it has to be perpendicular to the hypotenuse and connect to the right angle. So that would look something like this. Let's see if I can make it a little bit better. There we go. When you draw in an altitude to a right triangle, you create two similar smaller triangles. So if you notice, this diagram has 1, 2, 3 right triangles. And all 3 of those triangles are similar. Now the easiest way to know what sides correspond with what is to think about it as hypotenuses, short legs, and small legs. So if I label these vertices A, B, C, and then D, and I focus on the big side of the bigger triangle, so the hypotenuse, that would correspond to the hypotenuse of the smaller triangle, the medium-sized one, I guess you could say, which would also correspond to the hypotenuse of the small triangle. So our hypotenuses, going from big to small, are side BC, side AC, and side AB. From there you move to the legs. So our big leg for our big triangle, again we're looking at this big triangle, the legs are the two sides that form the right angle. Our big leg, or our longest leg, is AC. For our medium-sized triangle, that's DC. And for our small triangle, that's AD. And then for the small leg, it would be for our big triangle, AB, for our medium triangle, AD, and for our small triangle, BD. So there's going to be times where you have to match up the corresponding sides, and it's always easiest to go match them by hypotenuses, then try to factor in what's the big leg and what's the small leg. Okay? Because like I said, guys, eventually there's going to be a problem like something like this where you're going to know, like, this is 20, this length right here is 30, and then this length is, let's see, let's go long leg hypotenuse, 15, something like that. And so you have to think, okay, well, I'm looking at lengths from the big triangle and the medium triangle. So the big triangle's hypotenuse is 30, the medium triangle's hypotenuse is 20, the medium triangle's long leg is, the long leg of the big triangle is 20, the medium triangle is 15, if those triangles are similar, those should be equal. Now I just made those numbers up so they might not be. So what if we did this? What if I said I was trying to find this value right here? That would now be our x. So we've set up a proportion to now solve for x. Okay? So hopefully, guys, this is helpful, because I'm trying to focus on the types of questions you're going to see in the mastery tests. And there's definitely questions that focus on each of these topics. Usually there's multiple ones. So please reach out. If you take the mastery test and you don't do well, please reach out, and we can even go over some of the questions before you retake it again. All right?